In this very brief video, we're going to have a very quick look at the inbuilt MATLAB ODE solvers. So, as you might expect, MATLAB has a range of such solvers, and they all start with the letters ODE, and then usually there's numbers or numbers and a letter afterwards. So, for example, ODE 23, ODE 23S, ODE 45, etc. All of these inbuilt solvers are for systems of first-order ordinary differential equations. The ability of MATLAB to use vectors means that it can solve a set of first-order ODEs basically as easily as it can solve a single ordinary differential equation, so it's very advantageous. Now, the MATLAB syntax for ODE 45, and it's the same syntax for all of the other ones, is that we have an output vector, or an output pair I should say, t, y, is equal to ODE 45 with 3 input parameters. The first input parameter is a function handle that contains the right-hand side of the ODE, and for a set of ODEs it will be a vector function, so it will have multiple outputs. It'll have outputs that are a vector. Tspan has information on the starting time and the end time. In other words, when do we want to start, when is the final solution, final time step, and y0 is an initial condition, and for a set of equations it needs to be a vector. What are all of the variables y1, y2, y3 equal to at time is equal to t0? The outputs, first of all, are t, which is a vector of values of the independent variable, so here it's time. And y is a vector, or array, if you have multiple system of ODEs, of the dependent variables at the same times as are given in the vector t. So, we'll do some of this in the workshop. You can have a bit of a play around beforehand, but the key points that we need to get across from looking at higher order ODEs, you need to know how to convert a high order ODE into a system of first order ODEs. You will need to learn, and this is something that we'll do in the workshops and also in the computer labs, is how to code a system of first-order ODEs as a vector equation in MATLAB, and then to compare your solution to the inbuilt ODE solvers in MATLAB.